Sat Sri Akal students, today we are going to discuss parabola. What is a parabola? Para means far, bola means throwing. When we throw a ball, we know that it takes the shape like this in the air, finally falls on the ground. Here it is thrown at an angle theta with the horizontal. From this, shapes like this are known as parabola. Hence, this shape is also parabola. We want to study in detail. Students, we have in this parabola one straight line which is known as directrix. This is taken as the fixed line. The distance from this line is taken at different positions of generating point. What is a generating point? This point marked in red color. This point is the generating point. It can occupy any position on this parabola. For example, it's at P1, P2, P3. The moment of this generating point P is such that wherever it's on the parabola, its distance from fixed line, that is PB1, is always equal to its distance from a fixed point which is known as focus. Focus and directrix both remain fixed while generation of parabola. When this generating point occupies every position on this parabola, when it moves to P2, P2F, that is distance of the generating point from the focus, and P2B2, distance of generating point from the directrix, the vertical line. We know, students, the distance of a point from a straight line is always the shortest distance, and this perpendicular P2, B2 is the shortest distance. Both these are also equal. Similarly, P3F is equal to P3B3. This is how this point moves. Imagine, students, just imagine that this point, whether it can come here. Let's see, any point from which the distance from the focus and distance from the line is same is the point on the parabola. But this point, let's say this point name is X. This distance is smaller and this distance of the point from the directrix is bigger. So this is not the point on the parabola, right? This is the main theme, main understanding how parabola is generated. Let's go further. Students, by this figure, again we have explained all the black lines, thin black lines, 3, 3 dash, 2, 2 dash, 1, 1 dash, 4, 4 dash, and 5, 5 dash. These black lines are distance of generating point from fixed line, AB. This fixed line is AB here. And the corresponding distances are marked by red lines, which are distances of generating point from focus. Focus is O here. So we can say 3O, 2O, 1O, similarly 5O. They are the distances of the generating point from focus. Now, 3O would be equal to 3, 3 dash as shown by two lines. Similarly, 5O is equal to 5, 5 dash. So this is done. That's why this parabola is generated. This parabola. Now students, we also define something which is known as axis. What is axis? Axis is a straight line passing right, touching the focus of the parabola perpendicular to directrix is known as axis as shown here. And the point on the parabola, students, point on the parabola which is point of intersection of parabola, point of intersection of parabola with the axis, point of intersection of parabola with the axis. See, where the parabola is cutting the axis at this point, this is known as vertex of parabola. This is known as vertex of parabola. So now we are going to discuss the degenerating case of parabola. What is the meaning of this case? Degenerate. First we have generated the parabola. Now we want to degenerate, reverse engineering. Now we want to bring the focus on the fixed line. Once again, this focused O, we want to bring on the fixed line, directrix. So now see this figure. Here I represented focus with O. You can represent focus with F also. Call it F or call it O, doesn't matter. The O was initially here. O has traveled to fixed line. This is fixed line. That is your directrix. Now students, let's see how the parabola degenerates. Now, parabola was created by a generating point which occupied infinite position. All the positions that generating point occupied, they were equidistant from the directrix and focus. When the focus has moved to the fixed line, that is directrix here. Now, these are 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. How I have drawn 1 point? The condition is same. 1 point, this black line is showing the distance of 1 point from focus, and the corresponding red line is also distance of 0.1 from the fixed line. They are same. That was a condition for any point on the parabola. All right, 1 point is right. Now second point, again let us see the distance of this point from the focus to O. The red line is showing to O, and black line corresponding is showing the distance of point 2 from the fixed line. They are same, both are same. All right, similarly with 3, the red line showing the distance of, maybe you can say distance of 0.3 from the focus, same is distance of 0.3 from the line. Same with the case of 4, red line, black line. Case 5, red line, black line. You might consider black line is showing distance of 0.5 from the line, fixed line, directrix, and red line is showing distance of 0.5 from the focus. See this distance is equal to this distance. Wonderful. So that means I can say all these 4 points, 3, 2, 1, 4, 5 satisfy the condition of parabola, but we can see 3, 2, 1, 4, 5 points all line on a straight line PQ. So my parabola, which was having a shape like this or like this or like this or like this, has been degenerated into a, any student can say, has been degenerated into a straight line PQ. It's written here. Parabola is converted to a straight line PQ. Very good. So students, this is the case of degeneration of parabola. Now we want to discuss different types of parabola. For that, wait for our next video. Don't forget to subscribe our channel, Learn CBSE, Engineer Omkar Singh. We promise to bring you quality videos full of clarity and simplicity so that your interest in mathematics and physics is double folded. Don't forget to share with your friends if you like it. Thank you.